Hello, and welcome to this wonderful webinar with Kurt Cagle, Cagle with a long A. I have to remind myself because I've made a mistake in the past and called him Cagle. It's Cagle. And Kurt is the editor-in-chief of the Cagle Report. Kurt is a prolific writer. He is a longstanding practitioner in the field of ontology, data modeling, and all those interrelated disciplines. Kurt, it's a wonderful pleasure to have you in front of me today virtually.
Thank you.
You have a lot of irons in the fire. You're always doing something. Can you tell us a little bit about the upcoming book that you're writing?
Yeah, I'm writing a book called Ontology, A Layman's Guide to Language, and it's basically a book about the evolution of data modeling and data structures, and a look specifically at how the process of data modeling is actually going to be fairly influential, important in the realm of artificial intelligence, as well as providing kind of a primer, if you will. Don't know if that's primer or primer, but something like that. That basically looks at kind of the basics and the not so basics of doing data modeling and figuring out how that basically ties into representation of knowledge.
With that being said, if you need a steady hand to support you with any graph RAG implementations or any data modeling efforts, Kurt is your man. He's going to be talking today about AI and ontologies as standards, and this is going to be a open dialogue. So if you have any questions, feel free to chime in, and we'll address them as they come in. But other than that, Kurt, the mic is yours.
Thank you. So I don't have a presentation prepared today, and I'm going to apologize for that up front. But one of the things that I wanted to talk about was the notion of we're at a very critical stage right now. We're in the process of building out artificial intelligence, whatever that term may mean, and in essentially utilizing that intelligence to increasingly drive how we do business, how we interact with one another, how we evaluate and solve problems, how we create. And because of that, one of the key issues that you run into a lot when dealing with artificial intelligence, especially with generative AI, is essentially in trying to get the AI to tell you what it knows and what you'd like it to know in language that you can best utilize. Because when you work with an AI, what you're doing is basically querying what amounts to a great number of documents that have essentially been sliced and diced and put into a fractal form that essentially provides access to word combinations. So those word combinations are essentially building off of each of the documents that you put in. They'll see a word and they'll say, oh, okay, this is a word. It has these words around it. Basically, if I know this, and there's a certain level of probability that these other words are related to it in some fashion. And by knowing that, and by having that ability to look at these, and in many cases talking about, long strings of these words together with one word or one phrase in particular, what that allows you to do is to effectively create this information model that is not that dissimilar to the way that we store information in our heads. It's different, but it's not that different. The problem with this is that that model that you have is largely built upon chance. It's largely built upon what kind of information comes into the system, what kind of documents you're using, how you feed the underlying large language model. and even to a certain extent, the order that that information goes in. So as you are building up these models, or whoever is building up these models, one of the things that becomes very important is the ability to essentially say, look, there is a structure that I want you as a model to basically be able to follow. And that structure is, in computer science terms, it has a lot of different terms, or a lot of different names. It could be a schema, it could be a model or a data model. It could be what's called an ontology, which can be thought of as essentially a model that deals with multiple dimensions simultaneously. These all are basically ways of organizing information, and they kind of fall on a slightly different scale of AI than what we have with neural networks, which is basically what underlies large language models. So when you talk about a large language model, you're basically talking about, I have a lot of data and I'm going to try as much as possible to infer things based upon all of these documents, but you have to have a lot of documents. And finding those documents and finding documents that are dissimilar enough to be able to provide good examples is a lot harder, especially as you get into smaller and smaller models. So, the big models basically are able to do a lot of inference, but the smaller models often have much smaller bases upon which they work. And that often means that you don't have the variety that you like, and you don't have the structure that can be inferred. So an ontology is one way of essentially telling the LLM, this is how I want you to think about the relationships that exist in your model. And that ontology isn't something that's hard and fast in an LLM. It's kind of it's guidance. It's a way of saying, think about this in these terms. And as you're adding in more content, when you're parsing these out and using these to determine where that information goes, use this structure to give you that underlying sense of structure or building that makes it easier to then do things like making inferences, like saying, okay, if I know that these relationships are true, I have a cat. A cat is a pet. A pet is a kind of animal that has this relationship with an owner. Those kinds of rationalization, those kind of structures are things that if you can basically build into the model ahead of time, that gives you a significant edge in terms of how expressive your large language models become. Now, there are a lot of standards out there. There are a lot of different ways of being able to express structure. Most of those predate AIs. Most of those were not really intended for AIs. But one thing that does happen is that when you have an ontology is basically an expression. It's a set of rules, if you will. It's rules that say, here is how these things go together. Here is how I want to create my language, whether that's language of supply chain management, or of medical devices, or of library terminology and classification. Those rules are important. Those rules basically tell computer systems, as well as human beings, how to be able to find what you're looking for, how to be able to structure what you're looking for so that it's useful for other processes, for things that aren't just LLMs. They're very useful when you start adding in capabilities such as Copilot, or the OpenAI APIs, and that's hard to say, or something from Gemini, or some of the others, Mistrals and so forth. These all basically don't have these things implicitly built in. But if you can basically feed these things in ahead of time, or in a somewhat lesser case, if you can apply these using RAG or other retrieval generative mechanisms. This does give you a structure that you can basically then utilize to be able to make your applications much more powerful. It means that I can go in and say, hey, I have this structure that I'm wanting to utilize. Here's some examples. And keep in mind, examples are very, very useful to LLMs. But here's some examples that basically illustrate what these structures can do. And here's a definition of how those structures play into it. That will give you, when you then make a request, will bring back as part of the response to the prompt, the template, or similar pieces. That basically then will much more likely give you what you're looking for. It reduces the level of hallucination because there is essentially a compact that you're saying, that you're agreeing to with the large language model, to say, I want this information in this structure. I want this information in JSON or in XML, or give it to me in an Excel document, but I need these columns and I need these rows. And I need them basically structured in this fashion so that I can sort things according to number rather than string. That capability is something that I think is where knowledge graphs and ontologies basically come into fore, because knowledge graphs are essentially one way of building out those structures. Another way that helps is in the arena of classification. When you're working with information, oftentimes you have ways of classifying things. I want to talk about a country, but I want to talk about it in certain terms. Is that country a member of the EU? Is that country an island nation, or is it something that's landlocked? Is that country one where you have a high diversity of different religions, or one that has a single monolithic religion? Those kinds of classifications can basically, again, be put in as a taxonomy into the ontology that you're creating. And that in turn basically means that when you go back to say, how do I classify this? This classification engine that you built, this generative AI that you built, is much better able to then take that and ensure that the resulting data that comes back is classified to your needs and your requirements. The final piece of that particular puzzle is that when you have that ontology and when you have instances of that ontology, you can also then basically go back in and say, I have an identifier that's defined in that ontology. I have a way of talking about this person, and that person has a unique GUID or a unique URI, as the case may be, that says, this is how in my system I refer to this individual. And if I know that key, I can retrieve that person. Now, to give you an idea of what that means, if I go in and say, I'm wanting to find a person named John Smith, I'm going to get back a lot of different answers because there's a great deal of ambiguity. But if I have something in my system that I've added in as part of the ontology, saying I need to get John Smith 01205JS, and have to have the S in the end, then what that will do is that it will know, it will be able to say, aha, I have an identifier. I can retrieve the resource that's attached to the identifier because I know how to work with it. I can also basically store in other information such as, where is my database located? Where do I store the content that I have so that when you, LLM, go to find information, you can basically contact my database to get that information from my system as part of your processing. And once you have that information, then you can go back in and you can say, hey, here's the concept of John Smith, and John Smith is something that I can then clarify because I've got enough additional contextual information to then work with that information and make sure that I not only get back what I'm looking for, but what I'm looking for across multiple systems where I have essentially disambiguated the particular individual or the particular building or the particular company that I'm trying to seek. And this is important because if you don't have that, there's a lot of ambiguity. There's a lot of potential for getting back information that's wrong, not because it's incorrect, but because it belongs to somebody else. And so, that is one of the big problems that you have with an LLM by itself, is that it doesn't necessarily have any way to disambiguate, especially when you have common terms, except by utilizing some mechanism, some identifier that you can then build into the piece itself. That becomes very important because it then means that you have a much more reliable system. It means that when you go to pull information out, you're getting what you're looking for. It means that when you make a request against information, you can basically ensure that what you're getting is basically a class of people or even people who belong to this company. Because you have the ability to not only limit that set, but you can also infer from that set these relationships that allow you to say, okay, I have to be a part of Big Co in order to be able to be in this list of employees, which are classes. And those classes in turn can then limit what I'm looking for and make sure that I'm getting the right person or the right set of people. It also is something that you can then utilize to better give descriptions, to generate descriptions that are more accurate, to pull information in ways that you can effectively say, hey, this information is something that I don't want to have publicly made, but if you have this configuration of information over here as a user, I can let you see it. So it also plays a big part in the arena of security, in making sure that the data that you're working with is clean and is accurate, but also that you're not seeing things that you shouldn't be seeing. Not all hallucinations are induced because of random walks into liminal space. Many of them are basically things that probably just shouldn't have never been ingested, but it happens. And then finally, once you have that, you can then essentially transform it as needed into formats that are appropriate to whatever processes that you need, because it's unlikely, at least in the next few years, for everything to be in an LLM. It's unlikely that your processes are going to be things that are you're basically wanting specific structured content that you can utilize in other systems. And that capability is something that is actually a very definite one that LLMs are very good at, is the process of transformation. Now, the downside to all of this is basically that in order to be able to do this, you do have to have a fairly wide context window. And I'm not going to get into a lot of detail, but you can think of it as how much information can I handle, can I process at any one given point? How big is my buffer of information? It also means that you need to think more effectively about costs, because what you are doing, you can't just say, okay, give me 10,000 entries. Well, you can do that, but 10,000 entries is going to cost you a lot of money because it's a lot of tokens. So what you need to be thinking about when you're working with this then is, how do I effectively build out my solution to provide me the most minimal cost solution that I can get that still gives me the accuracy, the structure, the format, and the precision that I'm looking for in my content. And that is why standards are important. Ontologies are basically standards. They are ways of agreeing upon a common language, a common set of structures, and a common set of rules and constraints that exist and act upon the information that you have coming out of an LLM. They are ways of telling the LLM essentially how to behave, so that, you know, when you talk to it, it's not acting like a miscreant 3-year-old who's essentially decided to go off and color on the walls because, well, you know, that's what mommy does when she marks her paper. You know, that's, you know, we're still dealing with kind of that stage of mentality with most of our AIs. So that's really what I'm talking about here when I talk about ontologies and standards with regard to artificial intelligence. It's a way of structuring your information. It's a way of ensuring the cleanliness of the information. It's a way of ensuring that you have provenance and that you know where that data is coming from, and that's consistent. Thank you.
I just want to say I really appreciate you combining ontologies from the context of fair principles. Ontologies as a standard will allow us to develop things faster with a unified view of the world. An ontology is essentially a blueprint of the enterprise. It tells us how things interact, which actors are in place, what actions do they take, what events cause what effect on which actors and cause subsequent actions, and so on and so forth in a repetitive business life cycle. I like that you narrated the use of ontologies as a findable thing. You know, there's entity resolutions, there's IDs for particular ideas, and that provides a master data management solution across any kind of sharding of that entity across any part of different databases. You talked about accessibility via privacy and throttling access to certain sensitive information. You talked about interoperability, as in within the organization, we need to be able to reuse the same components that we create. We shouldn't be creating one-off solutions and then creating more one-off solutions. The one-off should be expanded and consolidate other interlocking parts in that overarching system architecture. And then the reusability, right? The interoperability and reusability are very entwined ideas. I think just to make a quick insight from all the other talks that have been given so far, it would be a silly idea to go to an architect, a physical architect, and tell him to build you a house, and he just builds whatever he wants. He just gets a construction crew. They start building, and then you say, "But where's my bathroom? Where's my room? Where's my living room? Where are the windows? Where are the doors?" You don't do that. You start with a plan. You start with a purpose. You designate the land, and you see, is this a suitable land for building a house? Is this suitable size for a 2-story? Are we compliant with the regulations of the municipality? I mean, if we were to transport that sort of thinking into the virtual space, the architectural blueprints for a house are ontologies as a standard within any industry.
Yes. I love that. I love that metaphor. I'm going to use it again.
Please.
I'm stealing your metaphor. I think that's great.
Take it. John asks a very pertinent question to this context. He's asking, can I apply different ontologies from the same enterprise to an LLM and expect to get a reliable result?
I'd say it's more likely. I won't say that you can't do it, or that you are going to be consistent, because there's a lot of different flavors of LLMs out there. And so to a certain extent, the kind of results that you get back probably need to be verified. and need to be tested before you can reasonably or before you can be comfortable about the reliability of the data. I think that it helps. I think that, you know, from the standpoint of any kind of structure, and hi, John, it makes a huge difference with regard to that level of interoperability, that level of being able to be consistent. But I would also say that, you know, in many ways, we're dealing with different ways of thinking about constructing, and I cannot guarantee that all LLMs think alike. So, you know, it's something you would have to verify, but I think by and large, yes.
If I may take a shot from the hip, also, it's can I apply different ontologies? To me, that implies that there are different ontologies and that they're not integrated within a higher level ontology. So I don't know at what stage this is integrated to an LLM, but I think that would change the nature of the answer, right, Kurt? If it's
yes.
a unified ontology, if it's multiple ontologies that are being federated through an LLM, I think that there are different architectural representations of this question. But I think you know, just to conclude the discussion, if anybody has any data modeling needs and they want to talk to Kurt further on establishing some sort of standard ontology within the enterprise, or leveraging off-the-shelf ontologies that already exist in the field, in the wild, curated by government agencies, Kurt is your man.
Thank you.
Be sure to check out the next presentation also. Alexander Garcia has a question, but I will let you go to that in the comments. If you guys have any other questions, feel free to comment below, and Kurt will get to it throughout the day, if not by the end of the week. If not, by next week, he will get to it eventually. So have a good day.
Yeah. Thank you. And one last